Hello friend, today in this video lecture we are going to learn the iteration method. First write the method of this iteration method. In iteration method, first we require one starting value of x for finding root of equation, that is f of x is equal to 0. This is equation 1. We rewrite this equation in the form of x is equal to phi of x, that is equation 2. There are many ways of doing this. For example, the equation x cube plus x square minus 2 is equal to 0 can be expressed in the different form. That is, x is equal to under root of 2 upon 1 plus x. That is, x is equal to under root of 2 minus x cube, and x is equal to 2 minus x square raised to the power 1 by 3 etc. Means first write this equation is equal to 0, then first take 2 on left side and common from x, and then by taking this square root and find this 3 value. Now let x0 be an approximate root of equation 2, then substituting in equation 2 we get first approximation. And that is x1 is equal to phi of x0. Successive procedure for substitution gives the approximation x2 is equal to phi of x1, x3 is equal to phi of x2, and that is so on. Xn is equal to phi of xn minus 1. The preceding sequence may not change, may not converges to a definite number, but if the sequence converges to a definite number, xi, then xi will be a root of equation x is equal to phi of x. To show this, let x of n plus 1 is equal to phi of xn. That is equation 3. With the relation between nth and n plus 1 approximation. As n increase, x n plus 1 tend to xi, and if phi of x is a continuous function, then phi of xn tend to phi of xi. Hence, in the limit we obtain xi is equal to phi of xi. That is equation 4, and which shows that xi is the root of equation x is equal to phi of x. To establish the condition of convergence of equation x is equal to phi of x, we proceed as follows. From equation 3, we have x1 is equal to phi of x0, that is equation 5, and from equation 4 and 5 we get xi minus x1 is equal to phi of xi minus phi of x0, and that is equal to phi minus x0 into phi dash of xi0. Here x0 less than xi0 less than xi. Similarly, xi minus x2 is equal to xi minus x1 into phi dash of xi1. Here again x1 less than xi1 less than xi. That is 6, that is 7, and again xi minus x3 is equal to xi minus x2 into phi dash of xi2. Here x2 less than xi2 less than xi, that is 8. and like this xi minus x of n plus 1 is equal to xi minus xn into phi dash of xi n xn less than xi n less than xi. That is equation number 10. And we assume mod of phi dash of xi I less than k for all I. That is equation number 10. From 6 and 9 to 9 gives that mod of xi minus x1 less than equal to k into xi minus x0 xi minus x2 less than k into xi minus x1 and so on xi n minus xn plus 1 mod of xi n minus x less than equal to k into xi minus xn. This is the equation number 11. Multiplying corresponding side of above equation, we get mod of xi minus xn plus 1 less than equal to k n plus 1 into xi minus x0. That is equation number 12. If k less than 1, that is mod of phi dash of xi I less than 1, then right side 12 tend to 0. That is mod of xi minus x0 tend to 0. And the sequence of approximation x0 x1 up to the term xn converges to xi. Hence, when we express the equation f of x is equal to 0 in the form of x is equal to phi of x, then phi of x must be such that mod of phi dash of x less than 1. The root obtained above procedure is unique. Root obtained by above procedure is unique. And second, mod of xn minus xn minus 1 less than 1 minus k upon k into epsilon, and which can be used to find the difference between two successive approximation to achieve prescribed accuracy. Then write the problem. Example. Find the real root of the equation x cubed is equal to 1 minus x squared on the interval with an 0, 1. And accuracy is 10 raised to power minus 4. First write the given problem, given function solution. Let f of x is equal to x cubed plus x square minus 1 is equal to 0. We rewrite this equation as x is equal to 1 upon under root of x plus 1. That is equation 1. Here we denote phi of x is equal to 1 upon under root of x plus 1, that is equal to x plus 1 raised to the power minus 1 by 2. Then phi dash, we differentiate this phi of x, then we get phi dash of x is equal to minus 1 by 2 into x plus 1 raised to the power minus 3 by 2. And also find the mod of phi dash of x. Here put x is equal to 1, then value of this is equal to 1 by 2 into 1 plus 1 raised to the power 3 by 2. That is equal to 1 upon 2 into under root of 8. After calculating, and this value is equal to 1 upon 4 root 2, and that is equal to k and less than equal to 0.2. After calculation of this is equal to less than 0.2, and therefore the second step is mod of xn minus 1 less than equal to 1 minus k upon k into epsilon. Here 1 minus k 0.2 upon 0.2 and epsilon is given as 10 raised to the power minus 4. Therefore, put this value 10 raised to the power minus 4. After calculating, this calculation is 0.0004. And first we take x is equal to 1. Then this difference is given by this. Then taking here x0 is equal to less than 1. Taking x0 is equal to less than 1, that is equal to 0.75. Then find x1. x1 is equal to 1 upon under root of 1 plus x0, and that is equal to 1 upon under root of 1 plus 0.75. After calculating, this value is equal to 0.75593. Then find x2. x2 is equal to 1 upon under root of 1 plus x1, and that is equal to 1 upon under root of 1 plus 0.75593. After calculating, this value is equal to 0.75465. Again find x3. x3 is equal to 1 upon under root of 1 plus x2, and that is equal to 1 upon under root of 1 plus 0.75465. After calculating, the value of x3 is 0.75493. Here we see that x2 and x3 has same value after decimal after 3 digit from decimal point. After decimal point, value of x2 is 754, and here x3 also have same after decimal point 754. Therefore, now we take the difference of this x3 minus x2, and that is equal to mod of 0.75493 minus 0.75465, and this difference is equal to 0.00028, and this difference is also less than equal to 0.0004. Hence the required root of equation is the required root of equation is 0.7549. Correct to 4 decimal point. Thank you.